excited to be here today, and I'm the only person standing before you in the next break, so I'll try to make the session useful. So today I'll share some experiences working on building out and scaling experimentation at Airbnb. So specifically, we'll talk about the platforms we built, some of it as open sourced. In case you guys are interested, that showed up in the last questions asked, we do have open source tools for everybody to use. We'll also talk about the process we have at Airbnb and how we incentivize the people to follow those processes. So I believe most of the people are familiar with the growth of Airbnb. So in a few short years, Airbnb grew the number of listings from a fairly small number to over 4 million listings in 2017. How we achieve this is through empathy-driven, evidence-fueled. And that's through experimentation. So today I'll focus on 3 fronts: the platform, the process, and the people. So what do we mean by platform? Through building out a scalable and trustworthy platform, we can automate a lot of the best practices, we can scale our people, and we can share our knowledge. And in the process side, we want to stay hypothesis-driven. We want to keep monitoring and derive insights and action. And on the people front, we have built out an internal education process. We facilitate cross-functional collaboration, and we incentivize people to make the right decisions. So how we achieve that? Let's get to the boring stuff first. So platform. Automate and scale best practices through built-in internal tools. We also ensure the quality of data and computation by hiding away all of the complexities under the hood. And this is how we achieve that. So if we make a rough analogy, there are 2 components to the experimentation system. There's internal user-facing front end, which would be available and visible to everybody in the company. So it is internal to everyone who's in the company: your CEO, your developers, designers, data scientists, product managers. Everybody would have access to the same thing. I think transparency was just mentioned in the last talk about something that people care about. We don't want to do experiments in the dark. So having a front end that's available to everybody would ensure that nothing's hidden. Whoever wants to look, we can look and see what experiments are currently running, what are the key metrics they're impacting. So for the front-end part, we have 3 key components. One allows everybody to query and visualize data, well, everybody according to access groups. So we can query access data and visualize to identify patterns that can fuel our next hypothesis iteration. We have a reporting tool on A/B testing results. And we have another tool called Knowledge Ripple, which allows us to share not only the data, but also the knowledge associated with it. And underneath the hood, there are 4 components that enable this. So that's what we're talking about when we talk about experimentation. So treatment assignment, splitting users into treatment and control groups, event logging, so write down what the users see, what they are assigned into, so treatment or control group, what did the user do as a result of the experiment. And then there are 2 more technical components called data storage and ETL pipelines and compute framework. So this is a simple slide of a copy change A/B test. I think many people are familiar with this kind of A/B test. Airbnb does A/B test not only for copy change and design changes, but also for more comprehensive features. Personally, I work for the payments team at Airbnb. One recent experiment we ran is called Pay Less Upfront. So essentially, in the past, for any users of Airbnb, the guests need to pay the entire booking value at the time of booking. But through user research and the comprehensive data analysis, we came to the hypothesis that potentially, if we allow users to pay less upfront, they will be more able to afford to pay, and more users will be able to use our platform. So this is the hypothesis we proposed. Airbnb then conducted a lot of experiments to verify this hypothesis, working out the user flow. And at the end, we proved that yes, by allowing users to pay half of the booking value upfront and the remaining half a week before they check in. This way, we allow users to afford to travel more. So this is beneficial to our guests and also beneficial to our hosts. So that's another type of experiment we can run. So not just copy changes or design changes. So for this kind of experiment, what happens in the backend? First step is treatment assignment. In the production database, in the production system, we hash users into two groups. One group gets the default, that's the current baseline. The other group gets the treatment. For example, one group gets to pay full upfront, and the other would get to pay half upfront. We then deliver this experience and log the exposure for each user. The next step is we collect all the user action after they see this new feature. Did the user click the pay less upfront option? What did the user do? Did they succeed in checking out? After checking out, did they cancel more often? So Airflow is a job management tool, which will appear again in the next slide. So Airflow enables us to run a series of jobs, to run the jobs nightly, to consume events, and compute metrics that inform the next step. The next step is a UI that track experiments, track metrics, track touch points, and allow our PM and engineers to diagnose problems quickly. So the next component, Airflow. So Apache Airflow is an open source tool to author, schedule, and monitor workflows. So the developers in the group might be more interested in this one. It looks a bit scary, but really it helps us track the different ways we're computing metrics to make sure they're reliable, they're also on time. If something bad happens, the Airflow jobs can also help us monitor and diagnose. Now we're getting to the slightly more fun part. So first component of the platform front end is called Superset. Again, it's an open source tool. Apache Superset is an enterprise BI tool that helps us query and visualize the data. So what we can do with this is to identify maybe patterns, seasonalities, trends, and also identify user segments. These would all feed into the decision of what hypothesis to test next. So Apache Superset, again, is available to everybody in the company to see, given access rights. And for the more technically oriented, there are also two internal tools. One is called Airbnb, which is for the R users, and AirPy is for the Python users. So data scientists in the group can use these kind of tools to quickly access internal data and do common statistical analysis with pre-written packages. So we don't have to start everything from scratch. The second component of the front end is called ERF, an experiment reporting framework. This is the meat of the experimentation reporting framework, where a number of pre-selected metrics are displayed. Their baseline values, their treatment values, the delta, the p-value, and the trends are all pre-computed and displayed here. So as many speakers have mentioned throughout the conference, there are many nuanced statistical challenges to A/B testing. So by abstracting away those challenges and hide them underneath the hood, we can make sure that people using this tool have access to trustworthy information. So in this slide, we see a number of metrics selected. There are nice colors, red and green. So this already considers the directionality of change. Green means good, and red means bad. As for metrics, in case people are interested, we'll look at a number of metrics. First of all, number of bookings are important to Airbnb. On top of that, we also track the conversion and user satisfaction. For example, the customer tickets submitted and also cancellations. So we don't only want to track things that are good and confirm our intuition, but also we look for evidences that could refute our hypothesis. Next, there's a component called knowledge repo. So this one is not yet open sourced, or it's not yet in Apache, but it's still open sourced. So if you're interested, feel free to download and try it out. So what knowledge repo does is to connect not just the data, but also the knowledge associated with the data. As many speakers have already mentioned, So sometimes the knowledge with an experimentation can just be siloed. One group knows it, the other group might not. In a larger organization, this can especially become a problem. So instead of just storing the data from A/B testing, we also store the knowledge, the learning from the A/B testing. So for example, I would have a new member joining my team starting next Monday. One of the onboarding tasks for this new member would be to go into knowledge repo and read up all the experiments the team has run in the previous years. All the experiments set up, the hypothesis we set out to test, the results, and the learnings. Sometimes those knowledge posts can also contain next steps. So for a new person joining, they can look at the next steps and consider whether they can contribute right away to those next steps. So this way, we greatly scale our knowledge sharing. So instead of knowledge staying in people's heads, and when people move on, they take that knowledge with them, this way, with the knowledge repo, we can store the information, the knowledge, the learnings, the lessons learned in one place, accessible to the entire company. So with building out all these tools, Airbnb was able to greatly scale the number of experiments. So I don't have the very latest data, but the last time I checked is mid-2017, Airbnb runs about 500 concurrent experiments at the same time. That is a very drastic difference from about 3 or 4 years ago when Airbnb just started building out the experimentation platform when we run only a few dozen experiments at the same time. So next topic is process. Now we have this great platform. How do we ensure that people are following the right process? Process is very important, as Mats just mentioned. It ensures decision consistency across teams, and it enables us to learn from each other and share best practices. For a product development team at Airbnb and at many different companies, it follows a similar structure. There's a team lead, there's a data scientist, a software engineers, there's marketers, operations, product managers, user research, designers, finance, and so on. So with such a cross-functional team, sharing best practice is especially important. The data scientists and probably engineers come with more knowledge on interpreting the nuances of statistical tests, but others may not. How do we ensure that everybody in the team is making consistent decisions based on the right set of principles? And an organization can have multiple business units. For Airbnb, that means homes, trips, Lux means luxury retreats, and China. But for your organization, you can have similar structure where the company contains many different teams. How do we ensure that the different teams impacting similar metrics are drawing conclusions with a similar principle? And lastly, your company may have many offices. Last night at dinner, someone asked me this question: how many offices does Airbnb have? Actually couldn't recall from my memory, but here it is. So Airbnb has many international offices spread out across the globe. I'm sure many in the audience face similar situations with remote offices. So how do we ensure that people in different physical locations are still applying the set of principles that agree with each other? And our solution is processes. Ooh, this one didn't come out quite right, but we'll try to read it. Okay, so 3 steps to the process: before experimentation, during experimentation, and after experimentation. Before the experimentation, we need to make sure we're testing for a hypothesis instead of just fishing for results. So come up with a clear hypothesis, come up with clear goals you're measuring, one single KPI, a number of other metrics to help make the decision. Design the experiment well so that we can draw the right conclusion from the data, and also put a lot of emphasis on data quality. So come up with tests that we can check for data quality issues, missing data, data delays, incorrect assignment, pre-existing imbalance, and things like that. And for what metrics to track, this is a very important question. So coming up with the right output metrics that align with long-term business goals that are good for the customers. So we should only have a single goal for that. But with a single output metric, it's hard to draw a conclusion when something goes wrong. So how do we debug that? For that, we need a set of input metrics where they all come together and feed into the final goal, but they can help us diagnose if something goes wrong. An example would be our output metric could be number of bookings, but input metric could be something like contact to book ratio, search to book ratio, cancellations, contacts to customer support. And finally, by setting up a target and guardrail metrics, we can pre-compute the duration of experiment to run. So we don't check it every day and run into those statistical issues of false positives, or let it run for too long without drawing a conclusion, and thus wasting opportunities for other more important things. So that's before an experiment starts. During the experimentation, we have tools and platforms to help us quickly diagnose and make remedy. Let me ask a quick question for audience. When you run a new A/B test, what are the chances that everything comes out perfect the first time around? Let's say for a new feature development. 2%. 2%. Yep. So chances are something would go wrong if we're developing a completely new feature or a new product. So it's very important to set out the time to allow for iterating and look at data. If we see something bad is happening, detect it right away and fix it so we're not harming user experience. For this, we have internal tools. I'm only showing a quick screenshot here to demonstrate this is not real data, but we can demonstrate with algorithms if something is going wrong in a fairly short period of time, alert the engineers and the product managers involved, help quickly find the root cause, and then diagnose and fix it. And after, so when an A/B test concludes, should we just celebrate? Not necessarily. It depends on how the target metric is moving. So based on the various signals from different metrics, we should recommend clear action on either to ship it or iterate or fix certain bugs or change certain things about the feature so the next iteration will go more successfully. So with cross-functional teams sitting in different parts of the world and in potentially different business units, the process helps us consistently adopt best practices in before, during, and after, so the entire organization is making data-driven decisions in a consistent fashion. And last point is about people. How do we build an experimentation culture? For this, a few things that we have tried and proven to be helpful would be educate broadly, collaborate cross-functionally, and incentivize for outcome. In Airbnb, there's an internal education called Data University. It is to empower every employee at Airbnb to make data-informed decisions by providing data education that scale by role and team. So specifically, we have data education for everybody. For cross-functional teams, we have Data University offerings that focus on data awareness, access and visualization, how should we interpret experiments, and how to look at data at scale. For product engineering, so these are the engineers who would build out the new feature, we have data foundation workshops where they dig into the details behind in the code with treatment assignment, logging, pipelines, and metrics. They also get an introduction course in causal inference to help them really understand why we're running A/B testing in the first place. Like the previous speaker just mentioned, this is not obviously available to everyone. So with each new batch of engineers and PMs come in, we have these offerings at their onboarding first week. So they get a taste of what data-driven decision-making is about at Airbnb right away. They also get education on experimentation design and interpretation. So finally, we have a piece for data scientists and analysts too. So for this, it's called Engineering-Empowered Data Science Training. We teach our data scientists the data infrastructure architecture, logging schema design and testing, what is under the hood for treatment assignment, and how to monitor and diagnose root cause for problems. So this enables our data scientists to pay attention to data quality right away. As previous speakers have mentioned, data analysis is like garbage in and garbage out. If the upstream data quality is bad, it doesn't matter what fancy analysis we're doing, it's not going to be good. So final piece about collaboration across functions. So with the cross-functional team, different people can have different level of expertise in A/B testing. For Airbnb, we have 2 specific functions dedicated to experimentation. On the engineering side, we have a track called Software Engineers Analytics. On the data science side, we have Data Science Inference. So these 2 functions partner together. They have specific domain knowledge in experimentation, and they serve as a center of excellence for other functions within the company. So these 2 help other functions to diagnose experimentation problems or build out new tools to serve their needs. With these, we have data-informed software engineers, PMs, and data scientists, and cross-functional teams. And one additional piece would be we have an experimentation council. These are internal engineers and data scientists who have deep domain knowledge in experimentation. Sometimes an A/B test is fairly straightforward. Sometimes it's less straightforward. For example, Airbnb is a 2-sided marketplace with a supply and demand side. When we run certain experiments, the 2 treatment and control group can have interference. So the straightforward A/B testing would not work in this case. So for such tricky experimental design and interpretation, people can come to the experimentation council to get advice. So final slide on building an experimentation culture is to have smart incentives. One thing the team tried in the early days of building out the experimentation platform is to add something in people's performance reviews. So an engineer can quote that they successfully shipped a feature that resulted in X% gain in nights booked. This would be it would be considered highly in the performance review. Then we're aligning the individual's perspective and the company perspective and incentivize people to adopt experimentation in their daily work. Also in product launches, we also need to show target metrics are moving in the right direction by the right percentage we expected, and guardrails also remain in the pre-specified range. It's very easy to make tweaks so that the final one outcome metric is changing in the right direction, but we're hurting a bunch of other things. For example, where we could be optimizing for short-term gain in sacrifice of long-term gain. So by keeping everything in track, we incentivize people to adopt experimentation in the right way. So to wrap up, Airbnb was able to power growth with experimentation. But not every company has a large number of traffic like Airbnb does. So if you were to build out your own team, where should you begin? We can begin with hiring the right people with the right growth mindset, understanding experimentation, and willing to share knowledge. And with these people, we can then build out processes that ensure other functions are following the same set of principles in deriving their decision. And lastly, when you get to the point where people and process are not enough to scale with the company's growth, then it's time to consider building out the platform to further automate and scale. Questions? Also, last slide, I've included all the information that I've mentioned, the open source tools, Airbnb's engineering and data science blog, which contains a lot of lessons learned through our years of experimentation, and also some information regarding data university and how you might implement this in your own organization. So with that, I conclude my talk.